Good evening, children. In this class, we will be discussing about electricity, the importance of electricity, what is electric current, what is potential difference, Ohm's law, etc. So that is the basics of electricity we will be discussing in these PowerPoint slides. Go through them and go through the video class also. So together they can help you in better understanding. Electricity plays important role in our daily life. We can't imagine a day without electricity. That also in city life, everything, every appliance or instrument depends on electric current. You know that why electricity has become this much popular? The reason is simple, because of its convenience. A convenient form of energy which can be transformed easily to other forms. That's why electricity has become more popular. We get light, fans rotate, we can run a mixie, watch a TV, run a motor, charge a mobile, heat a room, or even you can cool a room, or you can use for cooling in refrigerators. Everything can be done just by using electric energy. So because of these reasons, electricity has become very important in our daily life. At the same time, just imagine how many gadgets you are using which are depending on electricity. Make a list, you get surprised. This slide represents how electricity can be transformed into various other forms easily. This made electricity a more prominent source of energy. In this slide, let us try to understand what do you mean by electric current? Heard of current? Water current. You know, flow, that is the current. Then what is electric current? Actually, what is flowing? Electric current means here electrons are flowing. Electric current is a flow of electrons. Then how do they flow? Electrons, they flow from a region of higher potential to a region of lower potential. Now here you are supposed to imagine water flowing from a higher region to lower region, from a tank which is in the upside of the hostel to the water tanks which are in the bathroom or toilets. So how it is coming? Because of gravity. From higher altitude it will come to lower regions. In the same way, from a region of higher potential, electric current can flow to a region of lower potential, but here potential doesn't mean the height. So in a simple way you can understand, electricity means, electric current means it is a flow of electrons. Electron flow from a region of higher potential to a region of lower potential. See this slide. Here there are two pictures, picture 1 and picture 2. Easily you can recognize, in picture 1, water will flow from first tank to second tank, will be flowing continuously. But in the second picture, water will not flow from any tank because the level of water is same in both. So that is what we call equal potential. So now the tank with more water has higher potential, tank with less water has low potential. At the same time, depending on the height also potential can change. This is regarding to water. In the similar way, as water can flow from a region of higher potential to lower potential, electric current will flow from a region of higher potential to lower potential. So what is electric current? Electric current is a ratio of quantity of charges flown in given time. Electron flow from a region of higher potential to lower potential, and that is nothing but we call as electric current. So electric current represented by I equal to Q by T, where Q is the quantity of charges flown and T is the time in seconds. SI unit of electric charge is coulomb. 1 coulomb means it is equal to charge of 6 into 10 power 18 electrons, or charge of 1 electron is 1.6 into 10 power minus 19 coulomb. Go to the video class so that you can get it more clearly. So this class is giving you a summary which will help you to make notes. As I have told you earlier, electric current will flow from a region of higher potential to lower potential. Then there is a difference in potential, a difference in energy, and that is called as voltage. It is the amount of work done in bringing unit charge from one point in electric field to another. See, now there is potential difference, then charges will flow. For the flow of charges, work is being done. So V are the voltage or potential difference equal to W by Q, where W is the quantity of work done and Q is the quantity of charges transferred. If 1 joule of work is done in moving 1 coulomb of charges, then we say the work is done, then the voltage is said to be 1 volt. Volt is the SI unit of potential difference. There are textbook examples. I will be sending the textbook extract pages also. So go through them, then try for better understanding. Electric circuit is a closed path in which current flows. In this slide, you have the diagram of a simple electric circuit which contains a battery, a lamp, and connecting wires. So observe this simple circuit and draw it in your notebook. Then if you add ammeter for measuring current, voltmeter for measuring voltage, then the load or the resistors, then it will be having more enhanced points. Then you may have plug key or the switches for switching on or off the circuits. But electric current flow is shown from positive to negative for convention that can be explained in the regular class. This slide is representing two circuits. Just observe there, we have one V means voltmeter, R means the resistance or the load, we will be studying in the next classes. Ammeter is connected along the series, we say, and voltmeter is connected parallel to the resistor. What is series connection, what is parallel connection? Day by day, after each class we will be understanding. So this is one circuit, and another typical electric circuit is being shown in the second picture. There you have open switch, that means current is not being flown there, switch is open. Then there is a resistance or load. Then what is resistance? Every load is a resistance. Even the wire, electric wire, will have certain resistance. So these are all the slides. Basically I am trying to give you a small picture about electric current. To have a better understanding, you go through the video class also. Then in the next slide I have given you one small video clipping of Ohm's law. Go through that. It will explain the relationship between voltage and current. Current flowing through a conductor is always directly proportional to the voltage. That has been explained by using Ohm's law. So Ohm's law is very important. V is proportional to I. So go through that in the next slide. Thank you.
Verification of Ohm's law. George Simon Ohm, a German physicist, established a relation between the current flowing through a conductor and the potential difference at its ends. This relation between potential difference and current is called Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor, provided the temperature remains constant. That is, V is directly proportional to the current flowing through the circuit, or V is equal to Ri, where V is the potential difference, R is the constant of proportionality, called the resistance of the conductor, and I is the current flowing through the circuit. R is equal to V by I is the mathematical representation of Ohm's law. Shown here is a circuit with a suitable voltmeter for measuring the potential difference V across a resistance box Q and a milliammeter for measuring the current I flowing through the resistance box. A rheostat is used for varying the current and potential difference in the circuit. Click on the key to close the circuit. Record the values of V and I in the observation table. Now vary the position of the slider of the rheostat and record V and I. Record at least 5 values of V and I by adjusting the position of the slider of the rheostat. Calculate V by I in each case. The value of V by I is found to be equal to a constant R, which is the resistance of the conductor, thus verifying Ohm's law. This holds good only if the temperature remains constant. The unit of resistance is ohm. The Greek letter omega is used to represent the unit of resistance, ohm. Click on the link provided to remember the relation between V, R and I. A simple way to remember Ohm's law is to visualize the triangle VRI. For finding the value of any of the variables, simply hide that variable and get the value of the hidden variable. Thus, when we hide V, we get R into I. Hence, V is equal to R into I. Similarly, if we hide R, we get R is equal to V by I. And if I is hidden, we get I is equal to V by R.